Hello, welcome back. The title here is called Adding and Subtracting Expressions. This is part one. Incredibly important topic here. I'd like you to solve every problem with me because the skills we will learn in this lesson will carry all the way through the rest of your education. You will literally learn this and use it forever. So here we're going to add and subtract expressions. Let me get my first expression on the board and then it'll be very obvious what I'm talking about. So here is our first expression, 2 times x plus 3 times x. Now what we want to do is basically simplify this thing. We're not trying to put numbers in for x and calculate. We know that x can have some value. We know it has some value, but we don't know what it is. I'm not giving that to you now. I don't want you to calculate a number. I want you to take this expression and make it as simple as you can, just like we take fractions and we try to simplify them. Now the number one thing for you to know is that the only way you can add things in algebra, to add terms, are if the variables match. And in this case, we have an x here and we have another x here. And the exponent on this is an invisible 1, and there's an invisible 1 for the exponent here. So the variables have to match and also the exponents have to match. So because they match, we have 2x and then we have 3x and the variables match and everything matches. Only thing different is the numbers. We can just say 2 plus 3 is 5, but not just 5, 5x. Because what's going on here, you can think about this x as an object. You can think about this x as another object. So instead of thinking of x, think about hamburgers or hot dogs or bananas or coconuts or horses or giraffes. It doesn't matter. But this x represents something, right? So 2 hamburgers plus 3 more hamburgers means I have to have 5 hamburgers. So a lot of students aren't sure why they have to have an x in the answer. Why isn't the answer just 5? Well, the reason is because you're not just adding 2 plus 3. You're adding 2 of these things plus 3 more of these things. And it's easier in your mind to think of them as bananas or something, coconuts. 2 coconuts plus 3 more coconuts. So I have a total of 5 coconuts, right? And that's why the terms have to match, because you really can't add coconuts to giraffes. If the variables were different, like if this were 2x plus 3y, then I would not be able to add them. You can't do anything with that because you can add giraffes to coconuts, I guess, but they're different and they're not really the same thing, so it doesn't make sense to add them. In order to add or subtract things in algebra, the variables have to be the same, and also the exponents, which in this case both are just little exponents of 1 that are invisible there, they have to match as well. We'll talk more about that a little bit later. Once the terms are matching, we say that these are like terms, and when we have like terms, we can just add the numbers and then the x carries to the end, because 2 coconuts plus 3 more coconuts is 5 coconuts. All right, let's take a look at problem 2. Let's say we have 7 plus 5 times a minus 2. How do we simplify this expression? Well, what are the like terms? We have one term that has a variable, so this is like 5 bananas, right? But then this term has no variable, it's not a banana term, and this has no a as well, has no variable, so it's not a banana term either, right? So because of that, we can't really add the 5a to either of them because this is different than this and this is different than this, so we just can't add these. But the numbers, of course, can be combined because there is no variable here and there is no variable here, so the numbers are like terms. That works just fine. Now, after a while, you won't have to do this, but in the beginning, it helps for us to move things around, right? So here we can just say that this is 7, and we know we're going to add the number, so we can take this 2 and we move it over here. But when you move terms around, the minus 2, the little sign or the operation right in front, it's attached to the 2. It's attached to whatever you're moving. Everything in life has a sign. The sign of this 2 is negative because there's a negative in front. The sign of this 5a is positive because there's a positive here. And the sign of this 7 is also positive, even though it's not there because the positive is invisible, but it's there. So when we move this 2 next door, we have to move the minus sign with it. That's what I'm trying to say. It's attached. It's like just stuck to it and it goes with it. And then the plus comes from here and then the 5a here. Now that they're written next to each other, it's very easy for you to see that we can subtract 7 minus 2 to get 5 plus 5a. Now, you might want to add these. You might want to combine them and write 10 down or something, but you can't because this is like 5 horses plus 5 nothings, 5 buffalo or something. And it doesn't make sense and you can't combine them. Now, one last thing, when you write the answer, usually you write the terms that have a variable first. And you know, when you add things, you can change the order of addition, right? 2 plus 3 is 5. and 3 plus 2 is also 5. So these are added together. I can flip the order and it doesn't change anything. So I can write this as 5a plus 5. That's the same reason that I was able to take this minus 2 and move it around, because when you add or subtract things, as long as you grab the sign with whatever it is you're moving, then you can rearrange things as much as you want to in your addition and subtraction. It won't change the answer. So the answer to this is 5a plus 5. Now you have to get used to seeing your answers to have a plus sign in there. And you want to, in the beginning, combine them. But you can't, because this is a totally different kind of term than this, because this has no variable. All right, let's see another example. What about 2 times b minus 9 plus 4 times b? Well, we have a number here, but we don't have any other numbers by themselves, so we can't combine the 9 with either of these things. But we do have a 2b and we have a 4b, so this could be like 2 buffaloes and 4 more buffaloes. Now let's spend a minute to write these guys right next to each other. We have 2b from the problem statement, and we want to combine it with this. We can move it next door, and the sign that is attached to it is a plus sign because it's stuck right in front, so we can move it right next door. And then the minus 9 has to go with a minus sign at the end because the minus sign is stuck to the 9. So when you're arranging terms, you have to grab the sign right in front. It is attached to it. It is very important. That's a great way to get screwed up when you move things around and you don't grab the signs also. So the plus 4b goes here and the minus 9 goes here, and then we can see more easily 2 plus 4 is 6b's minus 9. And we typically want to write the variable term first and any number terms, constant terms later, and so we'll say 6b minus 9. Now you might want to add or subtract this as much as your heart is telling you to do it. You can't. You can't do it because this is 6 cars, and this is 9 minus 9, I don't know what it is, but it's not cars, it's different. And so you cannot subtract them or add them. You have to leave it like this. And you have to get used to seeing that, because up until this point in math, we're used to getting numbers as the answer. Now before we go on, let me just show you what we're really doing here. If I tell you that you have the fraction 5/10, this is 5 slices out of 10 slices in a pizza. And you know that if you actually have 5 out of 10 slices, it's the same thing as 1/2, right? Because I can divide the top and bottom by 5, and I'll get 1/2. You know that. And you know that this fraction means exactly the same thing as this fraction. They look completely different. If you ask a 5-year-old what this is and what this is, they're going to tell you they're different. The numbers are all different, but we know what fractions are, and we know that they actually are exactly the same amount of pizza. What you need to realize when you're doing these problems is that the answer you get looks totally different than what you started with, but they are exactly the same thing. If I put numbers in for b, like b is equal to, well, you just put b is equal to 0, then this will go to 0 and this will go to 0 and you'll have -9. But if I put b is equal to 0 here, this will go to 0 and you'll still have -9. This expression looks different, but it's exactly the same answer for any value of b that you put in there. It's the same thing. This looks totally different than this. The number here is different, but it is the same thing. If I pick any number I want for a and put it in here, I will get the same answer here as I calculate here, just like in the fraction case. So when you're getting these things, it looks like you're getting things that are totally different, but in fact, they're exactly the same. Next problem, 10 plus 2 times y minus 8 minus 4 times y. All right, now what terms are like terms? Well, with the 10 and the 8, these are just number terms, constant terms. Those are like terms. We can combine those. And then the 2y and the 4y, these are like terms because it has the same variable, and also there's an invisible exponent of a 1 here in both cases, so they match completely, the variable and the exponent. So let's take a minute and combine these in a way that makes sense. So let's take the -8 and move it next door to the 10. So we'll have a 10 here. Remember, the number has a sign attached to it. It has to travel with it. So we move the -8 there. Then we have a plus 2y. That's written right from here. And since we moved this, the only thing left here is -4y. You see what we did? All we did is we take the -8 and we put it right in between here. So we have 10 minus 8, and then the plus 2y, and then the -4 just stay in place. But now the terms are right next to each other, and we know that 10 minus 8 is 2. And then we look at this and we say, okay, these are like terms also. In fact, we could just rewrite it. I'll rewrite it as 2 plus 2y minus 4y. Now we'll combine these. Here we have to think. We have 2y's minus 4y's. So what we have to do is we're going to basically subtract the numbers, and the y is going to come along in the answer. It's like 2 horses minus 4 horses. It's the same animal, so we can subtract them. What is 2 minus 4? 2 minus 4 is what? Minus 2. Because remember, when you start with a small number and subtract a big number, you can just reverse it and say 4 minus 2 and then put the negative on there. But since we have a variable there, the variable has to travel. If you think about it, if you really did have 2 horses and you subtract 4 horses from it, then I only had 2 to begin with, so I give those away, but then I give 2 more away. I must be in debt by 2 more horses. 2 horses minus 4 horses gives me a debt of 2 horses I owe somebody. The number minus this is the answer. Now, usually we want to write the variable term first. So here we have the number first, and we generally want to rearrange it. The negative 2y has to come out in front. The negative sign is attached to this, and the 2 has a plus sign attached to it. So really, this is the best way to write it. Either one of them is correct, but usually you want to write the term with the variable first, and then the number term at the end, negative 2y plus 2. This thing looks completely different than this. I agree with you, they look different. But if I put a number in for y, any number, negative, positive, 0, any fraction, anything, and put the same number in here, I will calculate the same answer, because this is just a messier way of writing this. This is a more simplified expression. And the stuff that we're doing here is very important, because when we solve equations, we're going to be doing this kind of thing for every single problem. Now, what about 8 times a minus 6 plus a minus 4a? We want to simplify this expression. So let's group the terms that are like. So this is 8 a's. This is an a. There's an invisible 1 in front, so it's a like term. And then this is minus 4a. So all the a's are all correct. So they're all the same type of term. So we're going to have 8a. We're going to move this to the end. We'll just move this next door, plus a, minus 4a. All I did was say this plus this minus this minus 6, because the minus goes with it. I'm going to move it to the end. I can rearrange my terms and put all my like terms together. This one I'm going to put at the end. Now, what is 8 plus 1? Because there's an invisible 1 here. That's 9. So I can write this as 9a minus 4a minus 6. And now, again, I have like terms. What is 9 minus 4? 5. So 5a. And so the answer is 5a minus 6. Now you have to get used to the idea when you're adding variable terms together or subtracting them, the variable just comes along for the ride. And the best way to think about it is 9 cheetahs minus 4 cheetahs is 5 cheetahs. That's why the variable comes down with it. Students like to do all kinds of things with this variable, but what really has to happen when you add or subtract it is it just comes along into the answer. And these terms are different because there is no variable here, so you're done. And that's as far as you can take it, 5a minus 6. All right, we're going to speed up just a little bit as we have the general idea here. What about negative 5 plus 9 times x minus 4 minus 12 times x? Let's rearrange terms. We have a negative 5 here. I'm going to take this negative 4, which is a like term, and write it right next door. The negative goes with it. The plus 9x is going to stay in place, and then the minus 12x has to come right here. Again, the minus 4, the minus sign travels with the 4, the plus travels with the 9x, the minus travels with the 12x. Now, what is minus 5 minus 4? If I start with negative 5 and I subtract 4 away, it comes out to negative 9, as we've learned before. And then we can add these terms as well, but we have 9 minus 12. The x's are the same, the exponents are all the same, so these are like terms. What is 9 minus 12? Well, we subtract the other way. 12 minus 9 is 3, but because it's backwards, 9 minus 12, it's really negative 3, and so it's negative 3x. So you can think of it as 9 plus a negative 12 if you want. You subtract them, and the sign goes with the larger absolute value. That's why it's a minus sign. The x just travels along. If I have 9 horses, and I subtract 12 horses, well, I owe somebody 3 horses. And so it's negative 9 minus 3x. Now, usually we want to write the variable term first. So this one, we're going to write first, negative 3x, and then the minus travels with the 9. This is the best way to write it, minus 3x minus 9. This is correct. This is better. All right. Moving right along, let's take a look at something a little larger. 2 times b plus 10 plus 4 times b minus 8 times b. All right, let's group all the like terms. This is a like term, this is a like term, this is a like term because all the variables are the same. So 2 times b plus 4b, and then minus goes with it, 8b. And then we have the plus 10, and then we have the minus 8. And now we've grouped all our terms together that are the same, and all of these are the same. And so we just add the numbers together. What is 2 plus 4? It's 6. So we have 6b. We still have to subtract 8 here. And then we can add these numbers anytime we want. 10 minus 8 is going to be positive 2. So we have 6b minus 8b plus 2. Now these are, of course, like terms. You have 6 minus 8. What do you get when you have 6 minus 8? You have negative 2. Basically, you subtract, and the sign goes with the larger absolute value. But there has to be a b there because these are like terms, plus 2. And you typically want to write the variable term first, which is exactly what we have, negative 2b plus 2. And that's the final answer. All right, only, I think, 2 or 3 more. Let's take a look at 9 times y plus 3 plus 4 times y minus 8 times y minus 2 minus 16. Now, we can tackle problems. There are many ways to tackle problems. I could do this another way, but I want to take the opportunity to do it a slightly different way. What we've usually been doing is rearranging everything so all the terms are together and then move along. But we don't have to do it that way. What you can do is recognize, okay, these are different, and of course these are different, but these here, they're already right next to each other, and they're already like terms. So we'll just do this first, right? We have 9y, we'll deal with that later. We have plus 3, we'll deal with that later. But we can choose to subtract these first. What is 4 minus 8? Because the terms are the same, we can just take 4 minus 8. And since it's a small number minus the big number, the answer will be 4, but it really will be negative 4, negative 4y. 4 minus 8, or 4 plus a negative 8 if you want to think of it that way, right? Because the sign goes with the larger absolute value, the 8 there. And then what do we have here? We have 2 terms that are also alike. This is the negative 2. You have to read this as negative 2. And this is minus 16 more. Remember, you have a negative number subtracting more. You have to kind of add these, but it becomes a negative 18. If you have negative $2 and I subtract 16 more dollars, you're really in debt $18. So negative 2 minus 16. So what we did is, because these were already next to each other, we would do that. Because these are already next to each other, we will do that. And then we can rearrange the smaller expression. We will have 9y. This one goes right next to negative 4y. The negative sign comes with it. Plus 3 goes right here, and then minus 18 goes right there. All right, so here we have like terms. We have y terms. What is 9 minus 4? It is 5. 5 what? 5y. It's 9 hamburgers minus 4 hamburgers. I must have 5 hamburgers. And then, of course, I have plus 3 minus 18. And I have to deal with 3 minus 18. What do you do when you can't do the subtraction? You just subtract as usual. 18 minus 3 is 15, but then you make it negative because it's backwards, right? The sign goes with the larger absolute value. So you have 5y minus 15. 5y minus 15, that is the final answer. All right, only 2 more problems. Let's take a look at 14a plus 8 minus 6a plus 4 minus 8a. All right, so I don't have any terms right next to each other that are like terms, so let's go ahead and just rearrange things as we've been doing. We start with 14 times a. Here is a like term. It has the same variable. The minus sign goes with it, so it's minus 6a. This is also a like term. The minus sign goes with it, minus 8a. And then we go back through and catch this term, plus 8 at the end. And this term, the plus goes with it, plus 4. And now all the terms are next to each other. And then we go left to right. What is 14 minus 6? 14 minus 6 is 8, so we write it as 8a. Rest of it, let's just copy it for now. Minus 8a plus 8 plus 4. Next step, I have 8a minus 8a. What happens there? It's 8 horses minus 8 horses. Well, you don't have anything left. You have 0 horses, 0a, right? And let's go ahead and add these. 8 plus 4 is 12, so plus 12, because it's positive 8 plus 4 more is positive 12. Now, what is 0 times a? Remember, a can be a number, But 0 times anything is just 0, so this whole thing just goes to 0. So really all you have is positive 12. That's really the final answer, because this term, 8a minus 8a, it just gives you 0, and then the answer you have, 12, has no variable at all. And the reason is because if you take 14 minus 6 minus 8, it turns out that there's no horses left, for lack of a better word. The variable term drops away. All right, last problem. Last problem. Let's take a look at 22 times x plus 1 minus 15 times x minus 10 plus 3 times x minus 4. Just like this. Now, again, I don't see any pairs of terms that are like terms sitting right next to each other, so let's go ahead and just rearrange everything. And we have 22x right here. This is a like term because it has an x to the first power, same as this. The minus sign comes with it, minus 15x. This is a like term, plus 3x. The plus 1 is a different term, but I'll group it with the minus 4, right? Or actually, there's a minus 10 that comes down here, and then a minus 4. So really all I did was write the same terms down in a different order where the variables are all the same here. 22 minus 15 is 7, but it's not just 7, it's x's minus x's, so 7x's here. We'll add the 3x later, and then we'll deal with the numbers later too. Let's just deal with all that later. Here, 7x plus 3x, these are like terms, they make 10x. So it's like 7 rabbits plus 3 more rabbits, you have 10 rabbits. All right, now let's start dealing with the numbers. What is 1 minus 10? You can't really do that subtraction, right? So just subtract as normal. 10 minus 1 is 9, but the sign goes with the larger absolute value, the negative here. So really it becomes minus 9. So we'll just erase that plus sign. The answer to this is negative 9. We still have to subtract that 4. So we have 10 times x. What is negative 9 minus 4? We go deeper negative, and you get to negative 13. So you essentially add these and make it negative. So you get 10x minus 13. And now you can see why it was so critical that we master the idea of adding and subtracting integers from before. We did the whole entire lessons where we just learned how to add and subtract negative and positive numbers, and it gets kind of boring to do it, but now you see why, because we're combining that with the idea of having these letters. And the only new skill here really is to learn to group these as like terms, put them next to each other, but you still have to do all the adding and subtracting. So you have to be really good at adding negative and positive numbers and subtracting them, so that that skill doesn't give you problems, and you can just focus on the new thing here. The main thing is you can only add or subtract things in algebra if the terms are the same. The variables have to be the same, and the exponents on the variables have to be same. And so like in this case, it's y to the first power, y to the first power, so we can add this. If this were a y squared, and this were a y to the first, we would not be able to add them. And we're going to do problems like that later. So the variables have to match, and the exponents have to match. When everything matches perfectly other than the numbers, then you just add or subtract the numbers like usual and carry the variable down. Because it's like 2 rabbits, subtract 4 rabbits, I must have negative 2 rabbits, or owe somebody 2 rabbits is what that means. So I'd like you to practice this. Please make sure you get all the right answers. Follow me on to part 2. We'll get a little more practice with adding and subtracting a little more complex expressions in algebra.